Good afternoon. My name's Regan. I am a Kiwi, so please don't hold that against me. I'm also from Microsoft, and I am part of the commercial software engineering team. And one of the things that we've encountered quite a lot lately is with this, everybody's really excited about containers and what containers can do in DevOps. And we're finding a lot of people are really keen to give this a try and see what they can do with their Windows systems, and especially some of their legacy apps. So that's what I'm here to talk to you today about. It's about moving some legacy apps that you might have on an IIS server in the back of your server room, and hopefully moving it forward to a container so that you can take advantage of some of the modern infrastructure, modern orchestration systems, get it into a CI/CD pipeline, and maybe just make it a little bit more easy to manage. As well as being a Kiwi, I also have to apologize. I don't have any fancy GIFs or animations or music. I'm not going to sing or anything else. So forgive me. If you want to leave, that's cool. When we start, we turn the thing on. That helps. When we're looking at applications and legacy applications, one of the things that we want to think about is why should we modernize it? What are the benefits that we might get out of it? So as I said, people might have a legacy app stuck on an IIS server, back of a room somewhere. Might be happy doing its thing. It might be happy doing its thing for another 20 years as it has for the previous 20 years. So maybe you don't need to move it. But there are some benefits that you can get out of moving these applications, potentially containerizing them, and some of those things which you can see behind me. If you have this on a server, it's pretty low efficiency because you've got one application generally per piece of tin. If you've got it on a VM, then you've got either one application per VM on a machine somewhere, which is taking up a lot of resources, or maybe you have lots of applications on this one VM, and if you go and tweak a knob on one of them, all of the other ones fall over and break. One of the problems that you have with traditional applications is inefficient sizes. Messing around with the applications can break stuff. And then if it has been sitting there for ages, nobody necessarily knows how to redeploy it. And if something goes wrong and you need to stand it up again, then you've probably got a problem. So there's a few benefits. I mean, you can read off the slide there, but increased density is something that you can get out of containers. If you've got 20 hosts now, maybe you can drop that down to a couple and load a whole lot of applications there. You can split applications up, change one application without breaking all the others and redeploy it as much as you like quite often. You can then change versions of parts of applications without affecting other ones, and build that CI/CD pipeline so you can press a button and a new one builds. So if a server dies, you can push button and replace. So why containers? One of the things with traditional machines is hardware, put everything on there. You've got CPUs, you've got RAM, you've got hard disks that are assigned to your application, your OS. We moved on from that and we went to virtual machines where we virtualized that OS, which is great. So you could then move a virtual machine from one machine to another and it would still pretty much run. But you were still duplicating the OS, you were duplicating the storage, you were duplicating the memory for each virtual machine that you created up. So one of the things that containers do is instead of duplicating the OS, instead of duplicating all the RAM that's taken to run that OS and all the storage that holds that OS, containers can basically share the underlying OS, and then the consumption layer is really what your application consumes on top of the OS. So if you have in fact, I think I have a slide, here we go, that looks a little bit like this. So if you've got a traditional VM running, you've got an application on it, it's hosting an OS, it's opening all its applications, it's using a set of memory. If you can imagine maybe each of those is taking up 20 gigs of RAM, for example. 12 gigs of RAM maybe the OS on each one, and 8 gigs of RAM maybe the application on each one. If you could take those two applications, containerize them and put them on the one host, then now you only have the 12 gig OS once and the two 8 gig applications once each, and basically save yourself 12 gigs of RAM and a whole lot of disk space as well. So I think the animation here shows you taking the two virtual machines, splitting up the applications, rolling them out into individual containers and putting them on a single host. higher density, saving a lot of time and effort. So overall, containers, they give you a lot of benefits. If you're a developer, want to change your application, then you can iterate fast on that. You can change the code, spin it up, test it, change it again. If you are adding features to your application, you want to get them out to your customers, then through CI/CD pipelines, builds, all the rest of that. Once you've committed your changes, it can go through tests automatically, and then it can automatically deploy out to your production systems. For containers, once they are built and deployed, they are immutable. So you don't have to go and change them, or you can't really go and change them. And if they die, you can just spin up another one and it can take its place. So it's a nice sort of paradigm from the dev point of view. So for developers, there's some great features there. For IT, cost savings on getting that efficiency, getting that density in there. There's a lot less effort generally for IT for redeploying something over and over again, because it tends to be scripted and built in a continuous manner. And then, if your application suddenly needs to scale, with containers, it's actually really easy to scale it out so that you've got 10 containers running instead of 1 container or 2 containers. The other thing that's really good about containers, and things that devs specifically love about them, is the works on my machine. And when you have a container, it works on your machine. Basically, you're taking that container, every part of your application is contained in it. You can move that to another place where containers run, and generally it will work on that machine as well, and another one. And if you have a look at Microsoft Azure, for example, we've got a lot of places where you can run containers, including our first-party Azure Kubenetes service. And then if you're looking at other clouds, there are also first-party offerings over there. AWS and Google both have Kubernetes services that you can run your containers on as well. And you can get offerings from some of our partners, Red Hat, roll it out, and then host your containers on those offerings as well. So this whole idea of building your application in a container, throwing it out somewhere to run, makes it much easier than having to tweak around, install files, and turn knobs to make sure it runs each time. So Windows Server containers. Who here has used containers before? A few people? Linux containers? Windows containers? Not so many. Okay, so Linux containers have been around for a while. They're very popular. They're becoming more and more popular every day. They've had quite a long history with Docker and Linux. Windows containers are a little bit newer than that. But that said, they're a couple of years old, good couple of years old now. So Windows containers come in a couple of versions. We have a Windows Server Core version, and we have a Windows Nano Server version. If you're going to build a container for Windows, your starting point is pretty much Windows Server 2016. So your first thing you're going to do is need to get your app to run on Windows Server 2016. The next point is you're going to have to choose whether it's going to be on a Windows Server Core container or a Windows Server Nano container. With Windows Server Core, you can pretty much run all of your .NET stacks. You can run 32-bit, you can run 64-bit applications. Most of the roles and things on Windows Server will work on there, so they're pretty versatile. Nano Server is a much more compact version of Windows Server container. It will only run 64-bit, but it does have good support for .NET Core and some of the roles on Windows Server, including IIS. So we've got Windows Server containers. We've got some legacy applications. How do we get from there to here, sort of thing? One of the things that we need to think about before we actually start migrating our application is, well, should we? Is the first question, and then should we migrate it? Should we rewrite it? Should we redeploy it, or should we just maintain our applications? So migrating, moving your application to Windows containers, taking what you currently have working and deploying it inside a Windows Server container, basically the same as it is right now. That's the first option. Rewrite, you could rewrite your application in a, if it's a .NET 1.1 application, for example, maybe you can go and rewrite it to the latest version of .NET, and then run it in a Windows Server container running the full .NET, or run it in .NET Core and run it on a lighter container with the .NET Core runtime. You've also potentially got the option to redeploy your application. So if it's running in IIS, maybe you could actually look at redeploying it to a PaaS service, so push it to Azure Web Apps, for example. So that's always worth thinking about as well. You don't have to go down the container path if you want to modernize an old application. And then the last one there, maintain it. Maybe there is no value in actually trying to containerize this thing. Maybe it's too hard. Maybe there's things that just won't work. Maybe there's no value to the business in actually moving it. So just maintaining it as a VM may still be a good outcome for a legacy application. So definitely something you should consider. And if you are writing a .NET application, .NET framework application, one thing that you should really look at these days also is whether you would write that in .NET Core. And that really opens up the ability for you to look at running it on Windows or running it on Linux. And that just widens your choice of where you can run your application, whether it's on different orchestrators, whether it's on really small IoT edge devices, or whether it's on Windows servers. So if you do look at .NET Core, it's going to give you a lot more opportunities if you're rewriting an app as to where you can run it in the future. And .NET Core has really broad support. Microsoft builds images based on Alpine Linux, based on Bionic distros, for Windows Server Core and for Windows Server Nano. There are multiple images there. If you can really squint, you can see some of them. But there are images which contain the SDK. So if you need to fire up a container to build your application, you can fire that in the SDK image. Then you can take the build output of that and you can publish it into a runtime container, which is a lot smaller, and then publish your container just as a runtime image. Yeah, that's across all of the stacks there. And one thing you might notice if you're looking at this, if you've got really good eyesight, but we've got a Bionic runtime up the top there, which is, my eyesight's not that good. It's 82 megabytes. The Nano server image that I've got on the list here is, where's the Nano server one? It's about 200 megs. Oh yeah, there's one down there. So it's about 200 megs. So you can see if you're running a .NET Core application on Linux, you could be looking at an image of around 80 megs. On Nano server, about 200 megs. And I don't have one in this list here, but if you were going to run that application on Windows Server Core, then probably about 5 gigabytes. So there's a little bit of a difference in the size of those images. And that's important because if you are orchestrating and scaling an application, if you wanted to take a container and run it 1,000 times, the difference between running an 80 meg container 1,000 times and a 5 gig container 1,000 times is it's a little, quite a lot. So this is an example of a legacy application here. This is one that I worked on in the 90s, early 90s, still in production in a few places. And it is one that I did some work with a customer to containerize parts of it. And what we have in this application here is we have a SQL Server, as most applications did. We have a middle tier server in this case, which was a IIS plus COM layer. We had a web server, and web clients would hit the web server. The web server would talk to the middle tier would do all of the talking to the SQL Server database, and so on. And then we also had some internal clients who would connect to the database directly using a FAT client scenario. And one of the things about this being a Windows environment was that all of this was all done using Windows pass-through authentication, and this middle tier talking back was also Windows pass-through authentication, but the web server was not. That was a different authentication scheme. So when we look at that application and we sort of think, what are we going to put into containers? I mean, there's an Active Directory up there as well. I didn't point it out. But yeah, so Active Directory, pretty much no. You're not going to put Active Directory into a container. It just won't work, and you probably wouldn't want to try anyway. SQL Server, yes, it is possible to put a SQL Server into a container. It's not really a good candidate to put into a container. SQL Server, by definition, has a lot of state held with it. SQL servers tend to need, really heavy IOs and storage. You tend to build them with dedicated storage. For a lot of these reasons, a container is just not the right place to try and build that, and especially the fact that there's a lot of state with these servers. The middle tier application here, this is actually, it's a stateless application. The middle tier can actually scale out, so we could have dozens of middle tiers running in this application. They can run independently of one another. So it could be a really good component to containerize. In this case here, it's tricky because it has a COM plus component running at the core of it, COM, DCOM, and it's requiring a Windows authentication. And that's going to make things a little bit sort of sticky when we go down the container stuff, and we'll look a little bit more of that later. And then on the web server side, this is a really excellent candidate for containerization here. In this case here, there are multiple websites on this web server. Each of those could be split out into separate containers and then managed as individual applications. There is no state generally in these web applications. All their state is held in the database. They can also scale out, so we could have multiple nodes serving our users. These ones here, they happen to be running in this application some classic ASP, some DCOM components, ActiveX controls, but those actually can work in a container, and we're going to have a look at that working soon. So when we're looking at this and we're deciding where to start with our containers, we're going to go straight to the web server part. And then, maybe we can come back and have a look at this middle tier as the next sort of cab off the rank. The web server this is the tier that's likely to have the most changes to it as well. If our devs are going to be tweaking the web portals and the websites and things, that's where all the code's going to get written. This middle tier component hasn't changed in 20 years. It's probably not going to change. So there's less benefits from being able to roll out app updates to that tier there. So another reason why you might not jump straight into containerizing that one. So get stuck in and containerize this stuff. So what are we going to do? This is where most of my Windows-friendly admins sort of go, Windows containers, where's the GUI? And they're like, oh, shit, there's no GUI. Now what? So yeah, Windows containers are headless. Windows Server Core is headless. Windows Nano Server is headless. So there is no GUI. You can't log onto it. You don't have all the management tools sitting there in front of you. You don't have an IDE sitting in there. So it's a bit of a paradigm shift for a lot of Windows admins and IT ops people. There is no GUI, so you've got to take a different approach to building and developing your applications. You can actually get a container up and running, connect to it, and do stuff inside of it. But you would typically only do that for debugging when you're developing stuff. When you're operating a server, you shouldn't really be going into each thing at the command line and doing stuff. That's where you use monitoring and diagnostics externally to monitor things. And if something breaks, then destroy the container and let a new one come up to replace it. But there are tools to get in there and play around if you need to. When you're building and deving for containers, you're going to really reconnect with the command line from ages ago. You're going to learn to embrace things like PowerShell. And there's a lot of commands and things that you'll find really useful when you're trying to get your application and get it running inside of a container. With a modern .NET application, it's pretty much as easy as deploy to container, copy website, run it up, and it works. And it's pretty straightforward. For a legacy app, generally you've got a lot of other stuff that you've got to deploy in there. You've got DLLs, you've got other components. You might have an old ODBC package that you've got to install. In the case of our middle tier, some MSI from some vendor that doesn't exist anymore, for example. Actually, this one does, but I've seen ones where vendors don't exist and you've just got an MSI package that you've got to somehow figure out what you want to do to deploy it. So a bunch of commands that you're going to get used to when you're working inside of Windows containers and deving and things are these. This is probably the IT ops people are going to have to learn this and help the devs get the stuff configured the first time. Go away. It's supposed to be ignoring. Sorry. Yeah, so the IT ops are the people are the ones that deployed the servers in the first place. They probably have the knowledge of how to do this stuff. They might not know how to do it with a command line, but devs and ops will work together to figure out how to get this stuff going. And then once it's been figured out and scripted, from there on in, it's a little bit of an easier ride. So as well as PowerShell, as I said, MSIs, a lot of MSI installers, generally people would run up the MSI and then there'd be a whole lot of GUI screens that you'd click through and type boxes in. It's headless, so you can't see a GUI when you try to install something. So you're going to get really comfortable really quickly with using setup flags and quiet install flags, and especially log files when you're trying to install stuff from MSIs, because most of the time an MSI is going to fail in the first couple of attempts, and you're going to be pouring through log files to figure out what was missing, what went wrong. Sometimes it's a dependency. Generally, when you go to install an MSI file, the dependencies might not install alongside of it on a command line because they kind of spin up a second process when you run setup.exe and it does it. So now you're going to have to figure out that you're going to have to install .NET 1.1 first and then go and run your MSI to get your application working. But yeah, log files you're going to get really friendly with, and MSIs and command line switches there. So when we've, and we can do all of that inside of a Windows Server headless node. We don't actually have to have a container at that stage. We can spin up a Windows Server, a Nano server, well, not for 32-bit, but a Windows Server core, and then figure out how to install our applications. And then we can take the learning that we get from that to build out our Windows containers. So when we're building up our Windows containers, we're going to use something called a Docker file. There's other ways to do it as well, but we're going to start with a Docker file. And a Docker file, just like in the Linux world, it's basically a set of instructions as to how to construct the resulting container that you're going to use. And it always starts off with a from, so from what base image, and then you're going to do a whole lot of commands to install things, add features, register stuff in the registry. In this case here, expose 80 means this container is going to expose port 80 for a web app to communicate across. An entry point here, which basically says when this container starts up and runs, this is what's going to run, and when it stops, my container will stop. We don't usually want that to happen with a web server. So we've actually got a little tool which is nice, which is called Service Monitor, which will sit there and it'll run and it'll watch the IIS W3C service running. And if it detects it stops, it will exit, and then the container will exit, and you can start it up again or create a new one. But as long as it's running, this will keep the container up and running. So installing a whole lot of things, and then the last thing we tend to do is copy our files and things for our websites into that, and then any permissions or ACLing and stuff that we want to do. Building from that file, so we've created these commands. We want to go and create a container image from that. This is where we're going to use something called Docker build. And we can do this on Windows 10, we can do it on Windows Server, etc. if we install the Docker tools. But we're going to go Docker build. I always like to tag mine with a name so that I don't have to use random names to connect to them. When you want to run a container image that you've built, you're going to have to map some network ports through. So in this case here, -P will say map port 8081 to the port 80 inside the container, because you can't run multiple port 80s on one machine from a networking point of view. -D will say run it in the background. Then you can also, once that container's up and running, maybe you want to connect to it to have a look at some logs, mess around with it. So then we can use a docker exec command, and the -TI will say, give me an interactive session and hold the TTY, or hold the text console. And then what we want to run, command or PowerShell. So what that'll do is it'll open a session into that container, and we'll get our command prompt or our PowerShell prompt, and then we can go and walk through inside that container as though we're just logged onto a server console. And then some other commands to show what's running in Docker and what images we've got, and more. So let's take a look and have a look at an application or a site that I have as part of this, which is the right window. Okay. Oops. I'm actually working in the Ubuntu shell on here, even though I'm working with Windows stuff. I could just as easily do this in a command.exe window, but I actually come from an old school of running Linux machines and stuff, and I actually quite like the bash shell for automating stuff. So I find myself working in here quite a lot these days. But I am in a directory here, and I have, in this directory, I have my Docker file, which is the instructions on how to build this. I have a folder called packages, which will hold any MSI packages that I might need to install. I've got a folder called website, which is all the files for my website that are in there. And then I've got a couple of scripts that I'm going to use, which I won't talk about just yet. But if we have a look, first of all, at the Docker file, and I'm going to open this up in Visual Studio Code. And what we're going to see here is, can you see that all right there? Do I need to zoom in any further? Right, okay. So the first thing that we're doing here is we're saying for this application, build it from the Windows Server Core container image, version 1803. I could go just Windows Server Core and it would just grab me the latest one, but that's a bit dangerous if you're building containers. You don't want to just use latest, because as soon as a new image is published, the next time you go to build, you'll get the new version, and maybe you don't want that next version just yet. You're better to explicitly tell it which versions and things that you want when you're building your containers. So the first step there is saying I'm going to use the base Windows Server Core image. I am building a web server here. I could have actually gone to the Microsoft/IIS image, but in this case, I just wanted to use the empty Windows one. The next command here is basically me saying I want to default to the PowerShell. So any run commands that I do inside my script will actually use PowerShell as their default language. And the first command I'm doing here is I'm doing a PowerShell install Windows feature web server. Normally I wouldn't include management tools, but I was trying to debug some stuff on an application. So for my dev image, I threw them on as well. But then the other bits and pieces of PowerShell to just add the features that you would normally do on a Windows server, to install IIS, to install static content, ASP, so this is classic ASP if you've got a classic ASP application. And this one here, particularly important if you're running 32-bit stuff, the WOW64 support, which is needed for the classic ASP. So that will go through, it'll install the web server, it will add those additional web features. Then there's a couple of other things I need to do if I'm doing 32-bit sort of legacy apps. One of them is I've got to set an app pool to use this enable 32-bit on Windows 64 flag. If I don't do that, then my 32-bit stuff is just not going to run at all. And this one here, I didn't technically need it here, but this is what I use to tell it to run as a network service for my IIS app pool. And best practice would be to not use the default app pool, but to actually create one and use it from scratch. But that's just about installing and configuring IIS. The next part here, again, I wouldn't normally put that into a production image, but this was, I was trying to debug some stuff in this image and attach some remote management tools, so I dropped it in to allow me to connect to the web server remotely. This command here will basically take all the files in my packages directory, which was this one here. And what you can see, I've got some DLLs in here, some ActiveX controls, and a certificate, and an MSI. So if I need to deploy these inside my thing and install them inside my container, I'm dropping them in a packages directory, copying that into the container, and then to install the ODBC, I've got this one here, which is doing a start MSI exec and pointing at that MSI that I've just deployed inside the container. And I'll scroll over a little bit more, you'll see /QN says do it silently. And then for this one here, you also have to, oops, gone a bit crazy on my drawing. You also have to accept some terms and conditions when you install, otherwise it'll all fail miserably. So, so I'm doing that there too. So that line there is going to install the SQL ODBC MSI client into my server. The next one here, I'm actually, first of all, I'm setting TLS on my network connection because by default things don't use TLS 1.2, and a lot of websites are suddenly starting to use this, so in PowerShell you're going to kind of force it that way. And then I'm actually just going and downloading a couple of files from GitHub and elsewhere into my machine. I could have also kept these in the packages file and uploaded them that way, but I just wanted to pull them straight from the web. The next bit here is actually where I am registering some of those DLLs, those ActiveX DLLs and things, but I've actually got that commented out right now because I want to show that it's broken, and then I'll turn it on and fire it up and we'll see it working. Networking, so port 80, because my web server is running on port 80 inside the container by default. The entry point, that was that monitor to monitor the web service running. And then the last step there was basically all my web files, all my ASP files, all my website files, copying them into the container as well. So in order to turn this into a container, this is where we've got to go and then build this. So this is the Docker file, and then we'll use the Docker build command to actually go and build that. And to save time, I have, let's go. I could have actually used Docker compose as well, but I just like scripting stuff. So I've got a command file here that I just run because I do it quite a lot. First thing I do is I stop any existing containers using a Docker stop command. I delete an existing container with a Docker rm command. Then I build the Docker file that I got there and give it a tag of web-booking so it's easy to talk to. Whoops. And then I'm going to run that up in the background, which is the -D, with a port mapping of 8081 on my local machine to port 80 inside the container. The name of it's going to be the web booking, and the image that I'm going to use is the web booking one that I created just up here. And then the last one just basically fires up a browser to take me straight to my web page. So when I run that, what you'll see when we zoom in a little bit, it's stopping that container now. It'll stop it fairly soon. It'll remove the other one, and now it's starting to build everything that was in that script. And the first bit ran really, really fast. And you'll see one of the cool things is it says here using cache. So when it builds an image, it basically builds it and saves it and builds it and saves it. And if you change something in your Docker file and then you go and build it again, it doesn't go all the way to the top and start over unless you change something at the top of the file. But it'll actually use the cache and then just add on a layer after layer after layer to get your final output. And this is the web page that's popped up. And if I hit the button here for look up a job and pop in a ID and a thing, then you'll see I've got some details from job that comes up. This is a container running on my machine. It's actually connecting via an HTTP to a server that's up in the cloud that's running that middle tier. And that is up here. And it's fetching the details for this job here for a broken laptop service. This website part here is kind of one where people go and book in laptops to get them serviced, or phones or other stuff. It has a lookup job. It also has a book in a job. So if you want to go and book in your laptop to get serviced, there's a booking form in here. This is a website that this is not the actual live version of it. The live one looks a lot prettier, and it changes every time the company does their branding. So you can imagine that companies quite often change their branding a lot. The devs want to go and change these websites. They want to tweak some things on the form. They want to put new pictures up. Being able to do this website separate from all the other websites that are in there, it's quite useful. They can go and change this, spin it up in container, test it, and then deploy it to production without breaking all of their other things. So the other things that I got up in here, the ActiveX test page, and this one here is throwing me a big 500 error. This is a page that, if I have a look at the code, where is my code? website. This is just a basically just a contrived example for ActiveX because I didn't want to dig into the other code, but this one registers an ActiveX control in my web server with this server create object, and that's the DLL that I'm calling, and then it just does some for loops to spit out some maths. I've been listening to Seth too much. So that's failing right now, and the reason that's failing is because we haven't actually set up our image properly. And this is where maybe being able to get inside this container is going to be quite useful to us. So let me just zoom in a little bit here. So if we wanted to get into this container and see what's going wrong, then we can do a docker exec -ti for hold the TTY and do it interactively. Web booking is the name of my container, and I just want to run command.exe. So now I'm inside that container, and if I do a dir, this is the files that are inside that container. And if I did a task list, I'd see the tasks that are running in there. So this is running IIS, and I know that there's a log file in my inet pub directory, so I'm just going to go cd to inet pub, cd to the logs. And cd into the w3 svc1, and then there is a log file there that may not be full yet. I might have to wait a little bit. Oh no, it is. Okay, so there's the log files from IIS, and what we'll see in here is, there we go, so server create object failed. So I know that on my web code, we tried to hit this page, there was an error, and it's given me the error here, which is kind of nice. I was expecting that. But now if I go back to my Docker file, and I uncomment out this one here that registers my DLLs. So that's registering that MSVB DLL, which is required because this stuff was written in VB6. And it's registering my DLL with reg server 32. So it's running that inside the container as it builds. So now what I can do is go back, exit out of the running container. I'll just do a quick docker ps. So this is how you can see all your running containers, and you can see my web booking one at the top there is running with the name of web booking. But now that I've changed that file, I'm just going to do a restart, and that's going to go and cause that to rebuild. And now what's going to happen is, because I changed this file at this line here, it's going to go to this point in the build process. It's going to start from there, and then it's going to rebuild everything below that. So we'll see that it's picked up the cache, and now it's going through, and in this case here, you can see it's currently executing the commands that are doing the reg server 32 against those DLLs. So hopefully that shouldn't take very long. And when that finishes, the website will come up, and hopefully the ActiveX stuff will work nicely again. Taking a little bit longer than I'd hoped. Oh, here we go. Okay, the last step's copying the files. Now it's spinning it up. Once you've built these images, starting up a new one and shutting them down only takes a few seconds, so it's actually quite good. So if I go and change a file on the website and then rebuild and start up a container, it can be done in like 30 seconds, which is pretty good. Now here's our website coming up, and if I hit the ActiveX test page, now you can see I've got a nice little table with some maths going on in there, which means that it's basically loaded up my DLL now, it's built into the image, and now all that stuff's working. Right. So that's just some basics around building out a Windows container with some Docker and using a Docker file to spin that up. Right now, all this is running on my machine. I've got Docker installed on my machine. Docker uses Hyper-V on Windows 10. I could be doing this on a Windows server or something else, but it's running these Windows containers on my machine. So the next thing that we might want to do is actually get this container running somewhere else. And something that's quite popular these days to do that is Kubernetes. How many people here have used Kubernetes? Cool. So Kubernetes is what we call an orchestrator. You build your containers somewhere else, then you provide them to Kubernetes, and you basically tell Kubernetes how you want your containers to run. You tell Kubernetes what sort of networking you want, how many of your containers you want to run, how they want to be load balanced, whether they rely on other containers, how you want to spread them out across your Kubernetes clusters. And you do that with a little file. You fire it there, and then Kubernetes will bring up your containers. It'll run them. If they die, it'll start them again. If you tell them you want 10, it'll create 10. If you tell them now you want 20, it'll go and add another 10 to that, and now you'll have 20 running. So Kubernetes is great. It's an orchestrator that does all these things wonderfully. It's got quite a lot of features. It's not the only orchestrator, but it has basically become the default orchestrator, I guess, and the most popular one. As I said earlier, it's got first-class support on Microsoft, Google. I didn't edit this from another talk I did, but Catalyst in New Zealand is a open source focused company that has their own cloud, and they built a Kubernetes service that you can access as well. So Kubernetes is becoming the default orchestrator for a lot of clouds, for a lot of hosters, and the rest of it. The other thing that's cool with Kubernetes is open source. Open source software is really good these days. You get a lot of people making contributions, feeding stuff back in, including Microsoft, including Google. And then there's also a good ecosystem of tools that go with this. Things like using Helm to do deployments instead of native Kubernetes YAML files, for example. So you can actually create right now a Kubernetes cluster in Azure, Azure, whichever you like. And you right now you use the container service to do that, or you will use something called ACS engine. But you can, if the container service, you can basically go through, click a few things, feed in a service principal ID, and then have a Kubernetes cluster with Windows nodes that can run Windows containers up and running in a few minutes, probably about 15, I think it takes generally. But that's really nice. So this one here is one that you kind of manage yourself in Azure and Google and AWS. There are Kubernetes services that are more PaaS, where they will upgrade the control planes, keep the Kubernetes version sorted out for you, do all the patching on your nodes and all that sort of stuff. You can't yet run Windows containers in those versions, but it is coming. So for now, you can spin one up using ACS engine. So when we've built that Docker file before, we've built an image, we're running it on a machine. In order to get that into Kubernetes and running, Kubernetes has to be able to access that image. There are a few different ways that you can do this. You could check your code in to a DevOps, into a source control system, which could then trigger off a DevOps pipeline to maybe build your code, build the container, push your container through a process to a container registry, and then Kubernetes could go and grab the next version. Or you could do that manually as well. And in this case here, I have just pushed my images from my machine up to a Azure container registry. I could have done it to a Docker Hub registry as well. One thing to be careful of here, and why I'm not doing it with this image today, is that the Windows Server images are 5 gigs, and trying to push that up from here up to the cloud is a bit slow on the Wi-Fi. And yeah, that's pretty common. So you can build your image, you can push the image that you've created on your machine up to a registry, or you can let a pipeline take care of it. Once the image is there, then you can use the default Kubernetes YAML deployments to basically describe what that container is and how it needs to run, and feed this into Kubernetes. And in the YAML file, we've got things like the name of the container. We also, if we're pulling it from a private registry, then we've got the registry address. And maybe we point it at a credential file so that we don't have our credentials in plain text everywhere. And then we'll have a service that's configured to say, this container needs port 80 redirected in from the public into that container. And then from the YAML one, we'll use a tool called kube control, kube cuddle, KUBECTL if you like. Lots of ways that people call it. But this is something you can install on your machine. It's in the Azure Cloud Shells by default. But to get your YAML file into a Kubernetes cluster, you just do a kubectl kubectl apply /f and then point it at your file, and it will deploy this file to Kubernetes, and then Kubernetes will pick it up, find your container image, turn it on, start it up, and have it running and map all the networks. There's some other commands that are useful there as well, and looking what's running and describing them so you can see if something's breaking. So let me jump over to here. So I have an ACS cluster that's up and running up in Azure. And where is it gone? Let me just bring it up. Okay, it's taking a little while. So while I am there, as I said, we use that little kubectl to do things. So I'm just going to do a get all. And what this is going to do is it's going to go and talk to that server and then just tell me everything that's running up on that server right now. And as you can see, we've got a couple of containers running. These ones here used, well, actually we've got one container running, and one of them is 000 there. But this is a nano server, so it was a little bit smaller. It was only a couple hundred megs to send up there. But yeah, it's up and running. If I have a look at this thing here, this is the container that's running, and if I go and tell it to describe this, then we'll see a little bit more about what's going on in that container or that specific instance of that container. Oh. If I type the, if I go describe pod, it will work. So this is telling me a little bit more. As you can see here, it's got, oh, sorry, I should look at here. It's got port 80 exposed on this container, state running. It's telling me a bit about the image ID and where it came from. And you know, there's a secret that was used to connect to the volumes there. There was one that was used to connect to the container registry service as well. But that's telling me that it's there. If I also have a look, that's the container itself. In my YAML file that I have, and if I just go and bring that up, let's get it out of the, no, not that window, sorry. The right window, where are we? Okay. Okay. So the YAML file, which is the one that describes this, at the top of it there, this is the container that it's running, that port that we saw. There's also further down on there, it tells that we've got a service that is attached to this. And this is where it's saying that we want to basically map on our Kubernetes cluster. We want to map port 80 incoming to that Kubernetes cluster to port 80 inside that container. And at this stage here, there's no IP addresses or anything like that there. Kubernetes will take care of that for us. And what we can do is we can actually go and fetch the information about that service from the cluster as well. And I'll just tell it to get all. But what this will do is it'll tell me what IP address the Kubernetes cluster is assigned to this container. And I can see that it is 23.101. And now if I go and jump up to my browser and throw that in here, I can see that I've got a container up there. It's just the default nano server container running the IIS default instance. So that's up and running on Kubernetes right now. That YAML file that we've got here, what I can do is I can actually just go and, sorry, I don't want that YAML file. I want to go to the annotates one because the other one takes too long to load up. So I want to go to this file here and just edit it. I'm just going to call it v2. So v2 is a container that I actually edited before, basically changed the default page and gave it some other stuff. So in this YAML file here, I'm just going to tell it now I'm going to use this v2 image. And then in my command line, I'm going to go kube control apply -f and then my nanotest.yaml file. Whoops, I'm not going to spell it right. Yeah, thanks. And what that's going to do is it's going to send this new version of the configuration file up to Kubernetes. Kubernetes is going to look at it. It's going to understand, as it says there, that the deployment has been configured. The service, nothing changed on. But what that's going to do is it's going to force Kubernetes to basically kill the container that's running and then replace it with a new version of that container. And because this is only a nano server, it's only a couple hundred meg, it shouldn't take very long. And okay, oh, that's it. The IP address hasn't changed. So it came up. It was running. It says here for 20 seconds. So it had already come up by the time it stopped talking. And if I go over here and refresh my web page, now we see the second version of that container. The first one was taken down. The new version was stood up, which has the application changes in it. And all we had to do the deployment of that was just tweak one little character in a YAML deployment file. So Kubernetes and Docker Swarm are ways that you can orchestrate these containers. So you can build these Windows containers. You can have them auto-build by a pipeline, pushed out to a container registry, and then your orchestrator can, when it's told to, pick up the new version, deploy it out to the internet. You can actually have something like a service mesh running to basically, if you put up the new version of your container, you could say, I want to send some users over to the old version, some users to the new version, and, run an 80-20 split while you're testing out the new version to make sure it's all good, and then perhaps route everything to the second one. But it's a nice way that you can orchestrate these things. You can run multiple versions, do testing and production and all that sort of stuff as well. So that was just a real simple look at Kubernetes. There are a few other talks here and a few other talks at some of the other NDCs which go much deeper into Kubernetes and how it all works. And our friend down the front here was doing a great session that I saw some of online the other day for Kubernetes from Oslo. So if you want to learn more about Kubernetes, I recommend you go and look up Kubernetes in Oslo. And sorry, what was the first name again? Shahid. Yes, that's right. So where's my PowerPoint? Okay. So that was just a quick look at Kubernetes. There are some things that, as I mentioned before, that middle tier that we had that was running the Windows authentication. There are some things with Windows Server and Windows applications that as my colleague says, the Harabi dragons. Authentication is, I mean, it's never easy, but in Windows containers, it's a lot harder than it has been in the past. Windows containers, you can't domain join a Windows container. So in the past, where you would run up a Windows server, you'd run up IIS, you'd create an app pool, and you'd set your app pool identity to domain user. Then that would flow through to talk to your SQL server, and all the magical authentication would just flow and work everywhere. You can't do that in containers. But there are other ways that we can do that. There's a concept called a group managed service account, which was brought in a few years ago. And there is a way to basically have your container run in the context of this group managed service account, and then all the processes inside that container will also run in that context as well, which is also a warning, because if you've got anything else that runs in there that could potentially go out and do things that it shouldn't do with those credentials. But yeah, you can't domain join a container, but to use GMSAs, your container host needs to be domain joined. So the host that's running your Windows containers will need to be joined to the domain. Basically, once you've done that and configured the identities, then to start up a container to tell it to use this, it's actually just a simple command which I've got on the next slide, or the next one. But basically, you can do a Docker run with an extra command to point at the credentials, and then it'll start up and it'll use those credentials. One of the other things is it's still a roadmap item for Kubernetes, for Kubernetes on ACS, Kubernetes on AKS. So right now, you can't really go and join your Kubernetes Windows nodes to the domain and have any authentication. So if you want to run authenticated Windows containers in production, you're probably going to have to go and look at Docker Swarm right now to orchestrate that, or do your own orchestration with your own hosts. But it is on the roadmap, so it will be coming. So enabling it on a container host, so if you've built a Windows server as a container host, basically you can just go in and use some commandlets to add the GMSA feature into your machine, and then get the account and install that account into the container host. And then once you've done that, there's a library that you can rip down, which will basically go and create a JSON file containing all the credentials that'll let you pass that to Docker, and then pass through that authentication into your container when you start it up. And when you start up your Docker container, then there's an extra command, the security option one here. And this is where you'll pass through the credential spec file, which will have that GMSA ID and password, etc. in it. And the rest of it's just the normal commands that you'll run. Once a container's up and running, you can exec into the container and then just use an NL test parent domain that'll tell you if your container is up and running and it can see the parent domain and it can do authentications to it. This will basically just tell you what it thinks its parent domain is and give you an indication that it's actually working. There is a really good walkthrough end to end up in GitHub if you want to grab it from there. And I will actually make these slides available somehow afterwards as well, so you can grab a copy of them as well. Maybe just email me or tweet me if you want a copy and I'll send them. But yeah, so you can start a container with these credentials, and then everything inside that container will run using these credentials. So if IIS is running in there, now the IIS process will be running as your group MSA account. And then if that account has been given permissions to read tables in SQL, for example, now your web server can then just go and read tables in SQL. So then you can get this kind of application that maybe requires trusted connections through to a SQL server, because not all legacy apps support non-trusted connections. They don't support standard SQL authentication. So there are ways to get that working as well. So I was going to jump into that. I don't really have time to dig too deep into the GMSA working, but all it really does in the demo is shows you some rows coming out of a SQL Server database, so it's not that exciting. My wrist is buzzing, so I'm obviously almost finished. So what's coming up? There's a blog post out there that talks about being able to run Linux containers and Windows containers on the same machine without having to run virtual machines to run your Linux containers in. The Docker client, if you enable the experimental features, you can actually do that already. So there's a blog post up there that you can hunt out and find quite easily. And then also Windows Server 2019, which is due out in the second half of this year. I'm not sure if there's any big events happening soon, but maybe there is. But you can see a couple of the big investments that they have in Windows Server 2019 there are around containers. The first one there is improved support, especially around the orchestrators like Kubenetes, so that they can basically connect storage, control your compute, and basically let you control those Windows containers on a Kubernetes cluster, just like you can do that with Linux containers right now. Additional support to make it work on Red Hat OpenShift, which also is another orchestrator which a lot of people are using. So if you're running Red Hat OpenShift, now you'll be able to, soon you'll be able to throw some Windows nodes into the mix, run Windows containers on Windows nodes, Linux containers on Linux nodes, and have mixed deployments, hybrid deployments. And they're also optimizing the images for Core and Nano further, getting them smaller, because smaller is always better in containers. And then there's more improved Linux support in general as well. So that Linux containers on Windows that we saw before, a lot more support going into that. And then Windows is also starting to roll out some tools by default that you'd normally find on Linux. Things like OpenSSH, curl, tar. So when you're doing mixed work with Linux and Windows, you'd kind of start to rely on these tools, and it's a pain when they're not there. So they're starting to roll those into Windows by default as well. Next steps, if you're interested in trying out some Windows container stuff yourself, maybe try and move some applications around. One of my colleagues, Paul Bauer, he built a workshop for the Australian Container Camp and also the UK Container Camp, which was a couple of weeks ago. But there is a link to Paul Bauer's GitHub repo up there. Inside that repo is another deck and PDF. And then a few demos that you can walk through, and then some labs that you can follow to go and build out Windows containers and get them up and running and get apps working inside of them. If you're new to containers or Kubernetes, my organization also runs these things called open hacks. We actually had a container open hack here in Sydney a few weeks ago. There is one coming up in Auckland in November, and I know there's a couple in the US and Europe coming up as well. But these are 3-day events where you come in, you work as a team to work through a set of challenges, which basically start off with getting Docker running on your machine and end up with doing orchestrating of workloads in Kubernetes across clouds with routing and redundancy and monitoring and all that sort of stuff. Not everybody that will come into these will get from 0 to the end, depending on their level of experience. And I find that the people that have some experience breeze through the first couple of exercises and then get on to stuff like learning how to do monitoring, learning how to do traffic routing and failovers and things like that. So they're a good event if you're brand new or if you're a little way in, to come in and scale up really fast, work with a team of people to get further. But anyway, keep an eye out for open hacks and come to Auckland if you want to as well. So that was me. Thanks for listening. Is there any time for questions, or are we all out? No, we're all out, sorry. Come and see me afterwards. I'm around. Thanks for coming along.